Let's use what we learned about exponential rules and logarithms to solve some exponential equations. So here our first equation is going to be 3 to the x plus 1 equal to 81. Now, one of the first rules we learned was the addition rule. If we have 3 to the x plus 1, that is the same as having these exponents added from bases being multiplied. So 3 to the x times 3 to the first power is equal to 3 to the x plus 1. So let's rewrite this. 3 to the x times 3 to the first power is equal to 81. Now, 3 to the first power, that's just 3. So now, let's divide this to simplify. Divide by 3. Divide by 3. 81 divided by 3, that is going to be 27. 27 is equal to 3 to the x. Now, 3 to what power is equal to 27? Well, 3 squared is 9. And then 9 times 3 is going to be 27. So that means x is going to be equal to 3. Here's our next equation. 8 to the x equals 16 times 2 to the 2x. Now this multiplication right here, I like having all of our x's on one side. So I'm going to divide this whole quantity right here by, this marker sucks. Ay, ay, ay. We're going to continue in red. We're going to divide this whole quantity right here by 2 to the 2x. And we're going to do the same right here. Now, before we learned that when we're dividing exponents, we subtract them. We subtract the exponents only if the bases are the same. But our bases here are not the same. What is something here that we can change so that we can use that rule about subtraction? Well, 8 is a power of 2. 8 is 2 cubed. So this right here, I'm going to write this off to the side. This is the same as 2 cubed to the x power over 2 to the 2x. So here on one side, remember, we can multiply these together. So this is 2 cubed raised to the x power. When we have that, we can multiply our exponents together. So on the top here, we have 2 to the 3x divided by 2 to the 2x is equal to 16. Now that we have the same bases, now we can subtract normally. This is the same as having 2 to the 3x minus 2x. Cover up the variables, we get 3 minus 2, which is just 1. So we're left with 2 to the x is equal to 16. Now, 2 raised to what power is 16? Well, we just learned that 2 to the third power is 8. And 8 times another 2 is going to be 16. So that's third times another one. So that means x is going to be equal to 4. Here's another question. Log base 4 of 64 is equal to 2x. Now, last video, we learned what logarithms are and how they're used to rewrite exponential questions. This is the same thing as saying log 4 to what power is equal to 64. So let's rewrite this so that way we can keep simplifying. So 4 to this power is equal to 64. 4 to the 2x is equal to 64. Now, let's think here. 4 to the 2x, 64. Well, is 64 a power of 4? Let's think here. 4 squared is 16. 16 times 4 is going to be 64. So 64 right here is the same thing as 4 to the third power. So we have 4 to the 2x is equal to 4 to the third power. Now, since this here says, this sign right here, equal sign, it says these two things are the same. These two bases are the same. And if they want to be the same, that means these two exponents have to be the same. So this question now just becomes, since we're just focusing on the exponents now, we can just look at it like this. 2x is equal to 3. And now, simple one-step equation, divide by 2, divide by 2. So we can say with confidence that x is equal to 3 over 2. Now, clearly, let's plug this back in the equation and see how it goes. X to the 3 over 2. If we had 2 times 3 over 2, let's say 2 times 3 over 2. The 2's would just cancel, meaning that the question would just be log base 4 of 64 is equal to 3. Saying 4 to the third power is equal to 64, which we just found out. Boom. Exponents.